Okay. So we washed out the mess of shaving cream from our last segment there, where we showed what shaving cream would do in negative air pressure. And now for our last part, we're going to put some soda in there. In this case, we're going to put some Mountain Dew inside and see how it's affected under negative pressure, particularly with its carbonation. Let's open up a can. And this can of soda has already expired according to its expiration date, so instead of drinking it, might as well use it for science. Pour it in here. Look at that fizziness. There. Okay. I'll cap it off. So what's going to happen when we put Mountain Dew under negative air pressure? Well, let's find out. Take our vacuum pump. Put it over the top lip here. Let's see what happens to all that carbonation. See, at negative air pressure, your soda will fizz a lot more. So there's a lot less resistance for the carbon dioxide to get out. So your soda does not fizz this much when you put it in a glass, when it's standing by itself. Back in there. See, it's fizzing and it's continuing to fizz, and it's doing it at a much faster rate than at normal air pressure when it's at negative air pressure. We'll let the air back in. Again, when you let that air back in there, it all rushes back in and makes the liquid jump. Now that we've let some of the carbonation out, let's try pulling the vacuum again. We should get a nice, another surge of carbonation come up here. Yep, I'd say your Mountain Dew is probably going to be pretty flat by now. Still got some fizzy activity going on there. Let my air back in here. I let it in there a little slowly so it didn't jump. I haven't tried this yet with Mountain Dew, but I wonder if that trick I did with the water will work with this since it's a liquid. Well, let's find out here. In fact, it will. Look at that. Mountain Dew is being held in there the same way as it was with the water. However, I am noticing the Mountain Dew is dripping. The water was not doing that. So there's something about the Mountain Dew that's still allowing air to get in there, or still allowing it to drip. Most notably, it could be heavier, but I wouldn't know. Doesn't come out fast, but it's definitely not holding it back like the water was. That about does it. That's part 2 of our little fun experiments here with air pressure. And you can try these experiments at home. You just have a glass jar with a hole poked in it. You get one of these little Reynolds handy vacs, and you can do your own little vacuum experiments like I was doing here.